Moving on to example 5, we're going to solve a system that has infinitely many solutions. First, we got to put this in augmented matrix form. And again, we're going to do the elementary row operations. In order to get rid of the 2, we need to multiply row 1 by -2, add it back to row 2. So again, we'll have a 1, 1, 1, 3 up top. So we'll have a 0 here. -2 plus 1 is -1. -2 plus 4 is 2. -3 plus 8, sorry, -3 times 2. Sorry, -2 times 3 is -6, plus 8 is 2. Now to get rid of the 1 on the bottom, we'll have a negative row 1 plus row 3. -1 plus 1 is 0. -1 plus 2 is 1. -1 plus -1 is a -2. And -3 plus 1 will be -2 as well. Now what we need to do, we need to get rid of the 1 on the bottom, and we also need to change the middle row to make that a positive 1. So what we're going to do, we're going to change the third row by saying row 2 plus row 3. As you can see, we'll still have the 1, 1, 1, 3 here. 0, -1, 2, 2 here. We'll have a 0, a 0, a 0, and a 0 on the bottom. Let's take the opposite of row 2 here, just to make it a little easier to work with. So here's our matrix. Now we could keep going to put it in a reduced row echelon form, but really, let's keep doing that. So we're going to have to change the top row to negative row 2 plus row 1. So as we keep going here, negative row 2, so -0 plus 1 is 1. -1 plus 1 is 0. 2 plus 1 is 3. 2 plus 3 is 5. 0, 1, -2, -2, 0, 0, 0, and 0. So now this is in reduced row echelon form. This tells us then that x plus 3z will equal 5. Y minus 2z will equal -2. Now to solve these, x will equal -3z plus 5. Y will equal 2z minus 2. Now since we don't have a value for z, our final answer will look like this. -3z plus 5, 2z minus 2, and z. And this is for any value, or for any z. Doesn't matter what z is, that's going to be our solution. Now moving on to example B, to put this in augmented matrix form, we'll have a 1, a 0 for the y, and a 1 and a 2. 2, 1, 1, 5. So again, in order to change row 2, -2 row 1 plus row 2. So that is 0. -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 1 is -1. And -2 times 2 is -4, plus 5 is 1. So here's our answer so far. Again, we'll have x plus z equals 2. Y minus z equals 1. So solving this equation for x, x will equal a -z plus 2. Y will equal z plus 1. So my answer will be -z plus 2, z plus 1, and z. And again, this is for any z. For this next example, you're going to need your calculator. So please make sure you have your calculator out as you start. Now, we can also solve linear systems with more than 3 variables or more than 3 equations, or both, by finding a row or reduced row echelon form. The solution set may become more complicated as illustrated in example 6. So what we have to do, let's create an augmented matrix of example 6. So I have a 1, 2, -3, 0 for W, and a -1. 2, 3, -4, 1, -1. 3, 5, -7, 1, -2. So here's our augmented matrix. Now this is a 3 by 5 matrix. Now remember, to enter a matrix into your calculator, you press the second X to the -1st button, scroll over to edit, edit matrix A. I have 3 rows, 5 columns. Now when you enter this, it'll go in across. So 1, 2, -3, 0, -1. You got to press enter each time. Then we'll have 2, 3, -4, 1, -1. And 3, 5, -7, 1, -2. You can go back to your main screen. Now, what we want to find reduced row echelon form. So get into your matrix menu and go over to math. You can scroll down to letter B here for reduced row echelon form. Press enter, it goes to your main screen. Second matrix, I want matrix A, so press enter on matrix A. Here's my reduced row echelon form. I'm going to take a picture of that so I can have it on my screen. So here's my reduced row echelon form. So what we can take from that, we can say that x plus z plus 2w equals 1. We can say that y minus 2z minus w equals -1. Solving for both of these, so we need to solve for x, we need to solve for y. That means x will equal a -z minus 2w plus 1. Y will equal 2z plus w minus 1. That means my solution will be -z minus 2w plus 1, 2z plus w minus 1, z, and w. So here's my solution. Every time that you get zeros in your bottom row, there will be infinite solutions. Moving on to example B. Again, put this in an augmented matrix. Again, let's enter this augmented matrix into our calculator. We can put it back in A. It is a 3 by 5 matrix. 1, 1, -3, 0, 1. 1, 0, -1, -1, 2. 2, 1, -4, -1, 3. Now again, reduced row echelon form. Here's my reduced row echelon form. Now you can do this by hand. It's just much easier, much more effective to do it using your calculator. So x minus z minus w equals 2, and y minus 2z plus w equals negative 1. Solving both of these for x and y, we have these two equations here. X is going to be equal to z plus w plus 2. Y is equal to 2z minus w minus 1. That means my answer, z plus w plus 2, 2z minus w minus 1, z then w.